What's up, guys? My name is Steven. Today, I wanted to talk to you guys about preload. What preload is, why you do it, and some common misconceptions around it. This is specifically in relation to the off-road world, so lifting a 4Runner, Tacoma, Frontier, Xterra, whatever. There's a lot of misconceptions, and I think that a lot of people don't fully understand what it is and how it actually lifts your vehicle and how it affects performance. So I have a super fast, quick and dirty video for you guys. I apologize in advance. It's not going to be the most flashy thing in the world, but threw together some graphs to hopefully help get the point across to you. So that being said, we can cut over to my really fancy PowerPoint over here, and we can get started. So what is preload? Most of you already understand this, but I'm going to go over it anyway. Preload is the initial compression that's applied to the coil spring before any external load is added by tightening the preload collars on the shock body. Now, this is almost always used, at least in the consumer market, just to gain ride height or to tune ride height up and down. Stole this picture, don't know where I stole it from, but you have examples of negative preload, zero preload, and positive preload. So the way this would work is we'll say that you have a 14-inch coil spring on a shock, which is very, very common. At zero preload, the spring length inside the coilover assembly would be exactly 14 inches. If you were to say add 2 inches of preload, it would mean that the spring length in the coilover with no weight on the shock at all is going to be the length of the coilover minus the preload amount. So if we have 2 inches of preload, you would have a 12-inch coil. The length of the coil would be 12 inches inside of the shock assembly. And then negative preload is almost never a thing in our world, so you don't really need to focus on that too much. But just imagine preload is basically how much you're compressing the spring with the threaded shock body or with your circlips before you put it on the vehicle. All right, so how do we determine ride height in the context of coilovers? So ride height is directly tied to the distance between your coil bucket and your lower shock mount. So as you can see in this super fancy image, I'll get my mug out of the way for you. You have your coil bucket, which is up here, and then you have your lower shock mount, which is down here. So if you wanted to raise the height of your vehicle at ride height, you would want that distance to be greater. And if you wanted to lower your vehicle at ride height, you would want to make that distance less. Now the distance is ultimately, as you can see, because there's a big coilover there, the distance is controlled by the coilover. And a coilover, for the sake of this example, there's a lot of things that go into a coilover, but we have our spring, which is right here, and then we have our shock body. So for the sake of this example, we're going to say that the shock body is basically anything that can't compress. So in this image, it's going to be everything in orange. And then ultimately, that equals your effective ride height is going to be the length of the spring plus the length of the shock body. Hope all that makes sense. We're just going to keep chugging along. Okay. Oops. What does preload not do? All right, this is where we get into a lot of the misconceptions. Preload does not make your spring firmer or increase the rate of the spring. And by rate, it means most coils are going to be something like 500 pounds per inch. And for this example, we're talking about linear coil springs. 500 pounds per inch in a coil spring would mean that if you take a coil spring and you put 500 pounds on it, the spring would compress 1 inch. And then being linear, that would mean that if you put on 1,000 pounds, it would compress 2 inches. 1,500 pounds, 3 inches, 2,000 pounds, 4 inches, and so on. And what we can do here is I can show you on this here, you can see the force curve, the plotting of the force curve of a linear coil spring. You can see it starts at 0 and goes up in a very straight line all the way up to 1,000. And the rate on this example is going to be 100 pounds. So my argument that I'm trying to explain is that preload does not affect the firmness of the coil. And you can see that here by we have two springs. One spring is preloaded 2 inches. You can see that here. And then the other spring is not preloaded at all. It's at 0. So what that would mean is if you were to take 2 shocks, one preloaded and one not, and both put, let's see, we'll say 600 pounds, you can see that they converge and that both springs under 600 pounds of force are going to compress an identical amount. So what that means is when you take your 5100s or whatever and you throw on 1 inch or 2 inches of preload, when you drop the weight of the vehicle onto that coilover, your spring is actually compressing the exact same amount as it would if it had 0 preload applied. Very counterintuitive, and this graph kind of shows it pretty well, where you can see that the flat line here on spring 2 is simply saying because we're preloaded 2 inches on an 100 pound per inch coil, it requires 200 pounds of force to overcome that initial preload. But once we do, the force curve is identical to the force curve that you see on a spring with 0 preload. So when you're, drop the weight of the vehicle down, your spring is acting as if it doesn't know about the preload, is essentially what I'm saying. The force curve is completely identical. So if this is the case, and a preloaded coilover and a non-preloaded coilover, the spring compresses the exact same amount, how do you get lift? That is the natural next question. And again, this is actually pretty unintuitive. So I'm going to go over here, and here we have 2 examples. We have a coilover 1 with 0 inches of preload and coilover 2 with 2 inches of preload. And I'll get this, I have a photo somewhere around here I'll grab for us. All right. So you can see here, the orange represents the spring, and the blue represents the shock body. As you can see, these are 2 springs that have no weight on them right now, and they're both 14-inch coils, but the one on the right has 2 inches of preload. So what that would mean was we spun up the threaded shock body. The spring at no weight is compressed 2 inches down to 12 inches. And we've exposed a little bit of additional shock body just because the spring perch is sitting higher up on the shock body. And you can see that in this photo here on the right. You can see there's more shock body exposed here and less shock body exposed here. So obviously, because there's no weight on the vehicle, they're going to be the same extended length. That makes complete sense. So let's go up here and let's do this. We're going to take the applied force of this spring, and we'll just say we'll put 500 pounds on it. All right, now let's go down and see what happened. So at 500 pounds, if we go over to our initial force curve, we'll go to 500, and we'll see that the springs are acting identically regardless of preload. They are both compressing 5 inches because it's a 100 pound per inch spring. Therefore, over here, you can see with 500 pounds on the spring, the 0 preload spring is compressing 9 inches, and the 2 inches of preload spring is also compressing 9 inches. So therefore, the ride height gains that you're getting from preloading a shock comes from the additional shock body that you're essentially exposing through the preload. When you move that collar higher up on the shock, you're essentially lifting the spring higher up on the shock, and that is actually where you get your ride height gains. You can see that we're getting our gains not from the spring, but actually from the spring sitting higher on the shock. So this is something that is very, very, very misunderstood. If you don't get it right away, don't worry. I didn't either. It took me a very long time to figure this out because it's very easy to assume that preloading a spring means the spring is resisting more. All right, so naturally, the next question that I'm going to get is, Steven, if preloading a coilover does not change the spring rate, why then is preloading a coilover so often associated with a loss in ride quality or a harsher ride? Now, the answer to that question is actually that when you lift a coilover through preload or through a lift spring or whatever, what you're doing is you're changing where your shock sits in its stroke. So if you had a shock that had 10 inches of travel and at your standard configuration you had 5 inches of up travel and 5 inches of down travel, when you lift that coilover, you're now, say you might have, say, 6 inches of compression travel and only 4 inches of down travel, or in some cases, more extreme, you could have 7 inches of up travel and only 3 inches of down travel. So what you'll end up happening is you'll be topping out that shock a lot. You'll be, running into a pothole or a bump or something, and those shocks are violently bottoming out just because there's not enough shock stroke in the shock anymore to accommodate the obstacles that you're encountering. So when you do preload a shock, it's not really recommended to crank it too high because, again, you want to have a good ratio of up travel and down travel. And now, preloading a shock will give you ride characteristic differences in the low range. And to explain that, we'll go over here to this graph here. So you can see that the force curves between the preloaded shock and the non-preloaded shock are completely identical only after we've hit 200 pounds of force in this example. Now what that's going to mean is that let's say that you are off-roading and you're lifting up a tire, one of your tires is totally off the ground. On the shock that has no preload, there is no force that is pushing that tire down outside of gravity. But with a preloaded coilover, you have, even if your shock is totally extended, you have 200 pounds in this example of downforce ready to go. So what that would mean is that if you're nearing the end of your shock travel, you want to actually have some level of force to push that tire down into a pothole, for example, instead of just letting gravity do it, because oftentimes gravity is just not enough. And you'll notice better ride quality when your tires are in contact with the ground. That is what you want. You always want your tires in contact with the ground. So a small amount of preload is always wanted in an off-roading example, and honestly probably across the board, because again, as you're off-roading, if you're nearing the end of your shock stroke, a linear coil, you're drastically reducing the amount of downforce that you have on that coilover, and you hit a bump, your shock might not have enough potential energy to get the tire down into that divot before the entire body of your vehicle just falls right into it. So again, preload is generally a good thing across the board, just the degrees to which you want to preload is going to depend on your application. You don't want to preload too much and you don't want no preload. But again, the core of the point that we're making in this video is that, again, regardless of no preload versus preload, your coil spring is going to perform exactly the same, and your coil spring is going to compress the exact same amount regardless of zero preload or adding preload. So hope that video helped. If you guys have any questions or comments, feel free to yell at me in the comments or compliment me. I am always down for that. But hope this was helpful, and I'll catch you guys later.